Hello everyone, I'm going to be doing a video on Lerp and MoveTowards and what the difference is, and I'll do my best to give an example maybe of what they're used for. Now the reason why I'm doing this video is because there's definitely some confusion on what Lerp is for. Everyone seems to know what MoveTowards is. It's pretty self-explanatory. You're moving from point A to point B. But with Lerp, it is commonly there's a common misconception that it's used as a start off quick and then slow down towards the end. Okay, so you get kind of this, it's kind of a cool looking smooth movement thing. It's not actually how it's supposed to work. Lerp is a short name for linear interpolation. And what that means is that you're going to be moving from point A to point B at a linear rate. Now if you think of a graph, if you just look right here in my screen, let's say this was a graph and this is our y, and this is our x. If I draw a line from 0, 0 to 1, 1, that line there, okay, is linear. It's parallel. But if I were to draw a line to say, if I did a line that was like, say, 0.6, 0.1, and then to 1, 1, that line is kind of curving. That is not linear. So again, if we were dealing with speed and your speed was like this, curving down, that is not linear. So if your speed is at this rate and the closer you get to your destination, the slower you move, that is not linear. Linear would be just a diagonal line, a parallel line to, say, a straight edge, a ruler. Okay? So if you're using Lerp to make your objects move smoothly, you're using Lerp incorrectly. Now, I will admit I used it wrong in one of my videos, so I'm here to redeem myself and explain the correct usage for Lerp. So, I have set up a little scene here. We have an object that's going to be using Lerp. It's this yellow circle, and I have an object that's blue, and it's going to be using MoveTowards. I also have a start position, which is this little green box, and an end position, which is this red box. And in the example, both of these objects are going to start here and travel here. Yellow using Lerp, blue using MoveTowards. In here, in the editor, when they're running, that's not going to look very different. This is not going to move smoothly like you're used to. It's going to move at a constant rate. So it's going to look the same here, but in the code it is very, very different. And I would say that Lerp's actually a little bit confusing while MoveTowards is not confusing. So we're actually going to do Lerp first, even though it's the more confusing. Because then I think when I show you MoveTowards and you see how much simpler it is, you're going to go, oh, most of the time I'm probably just going to need to use MoveTowards, not Lerp. Lerp is special. So let's start off with Lerp. So a couple of things we need first. We need to know our start position and our end position. So let's real quick make those objects. Public transform start position game object, public transform end game object. The next thing we need to know, because Lerp is based off of a factor of time, which I'll try to explain in a bit, we're going to want to know the time that we started moving. So we're going to do float start time, and we'll get that in a minute. And what we also want to know for efficiency's sake is the total distance to our destination. So I'm going to, now you don't have to do this part, this destination part, but for efficiency's sake I like to do it. So we're going to get total distance to destination. It's kind of a long variable name, but it's clear. Total distance to destination. So in our start, the first thing we want to do is get our start time. Start time is going to equal time dot time. Pretty simple. Okay, just a timestamp of when we're going to begin movement. The next thing we want to do is get our total distance. So total distance to destination is going to equal, and I'm going to move this over, is going to equal our start position game object dot position. Oh, what on earth am I doing? It's going to be a vector3.distance call. We want the distance from the start position game object to the end position game object. Okay, so that's going to be the total distance in meters, how far apart these 2 points are. Okay, So that's all we need to do for setup. We need to know what time we start, and then as a little extra tidbit, we want to know the distance, so we don't have to calculate that every single frame. But if you don't care about this, you just need to know the time you started. So now what we want to know is, in update, every single frame, we want to calculate how much time has passed since we started moving, and I'll explain why in just a sec. But let's just get the variables down, and then I'll kind of go over why we have them. So the current time, or let's call this current duration, is going to equal time.time minus start time. And what this is going to do is, if time.time is 1 billion seconds, and or 1,000,001 seconds, and start time was only 1 billion seconds, then our current duration is going to be 1 second. Okay, that just means that this has been running for 1 second, and that number will get larger the longer the code runs. So the further we get from our start destination, the further we get from our start position, the more time will have elapsed, and eventually current duration will equal the distance. This is a float, this is a float. So if this is 10, then this means after 10 seconds, these numbers will both be 10, and using Lerp, we will have arrived at our destination. Sorry, I kind of stuttered like a ton right there. So what we want to do now is get the fraction, our journey fraction. Journey fraction equals, we're going to do our current duration divided by our total distance to destination. You can see now why I got that variable. It saves us a lot of lines, a lot of code. So you're probably really, really confused on this line because we're dividing time by distance. Like I said, linear interpolation is a constant rate. Basically, it's like moving a meter a second. We're looking at distance as equivalent to time. If I need to travel 1 meter, then using Lerp, it's going to take me 1 second to move 1 meter. If I'm using Lerp and I need to travel 10 meters, it's going to take me 10 seconds to move 10 meters. 1 second travels 1 meter. You can adjust this by adding a speed variable in here. So I could do this and multiply it by some speed variable. Now, if you do this, you cannot, I repeat, you cannot adjust speed halfway through, because this is a factor of time that is equivalent to distance. So let's say that I'm moving at a speed of 1 and I'm halfway to my destination. If you then change speed to 2, the next frame it's going to assume you've traveled double the distance and you will suddenly be at your destination. If that doesn't make sense, that's okay. Just take my word for it. If you're going to use a factor of time here, if you're going to multiply time, you can't change it. It has to stay constant. Maybe have time be a private variable and never change it, okay? But for the sake of this example, we don't need to change the time. You just need to see that it's going to be the seconds equals the distance. So now that we have this information, we can actually call Lerp now. So we're going to do transform.position is going to equal, this isn't plus equals, this is just we're going to replace position with a vector3.lerp. Okay, lep, whoopsies, Lerp. Now, this is where, well, let me put it in here. We're going to do start position, dot position, end position, dot position, and then our journey fraction. And let me explain why we're putting these variables in. What you're probably used to doing is you put in your current transform position here, where you're going here, and some kind of time calculation here, like time.delta time times speed. This is probably what you've done before with Lerp if you aren't sure how you were supposed to use Lerp before. Let me explain really quick what that does. If you put in your current position and you're basing everything off of a percentage, remember this is going to be a 0 to 1. If we haven't started yet at 0, if we are at our destination, then this fraction is going to be 1, okay? So if we're doing everything off a percentage and you're putting the current position, then here's what's gonna happen. let's say, this is if you did it wrong. Let's say you need to travel 100% of a distance. And every single frame, you're going to say move 10% towards the destination based on where I'm at. That means that in the first frame, you're 100% away, move 10%, you now have 90% of the distance left to go. Next frame comes around, and you say, again, move 10%, okay, because that's your speed calculation. But because you're doing it based off of your current location, you're no longer calculating off of the 100%, you're calculating off the 90%. So 10% of 90% is 9. So now you're only going to move to 81%, which means you've moved a little bit slower that frame than you did the previous frame. Now, next frame, on frame 3, you're saying, what's 10% of 81? And so every single frame, you're going to move slower and slower and slower and slower and slower until you finally get to your destination, which you might actually never make it to your destination. It'll get so, the decimal will get so small that eventually the compiler will just, or whatever, the runtime will round up and it'll say you're here, but it will take forever and you'll never actually get there. And that's what gives you that cool looking effect, but it's a byproduct of a mistake. That's all it is. So let's go ahead and see this in action. I hope that made sense. So we're going to come over here and we're going to do to our Lerp object. Now we need to get our start position, so let's click them. Let's drag that there. End position, let's put it there. And now let's click play. What you see here is this object moving at a constant rate. Doesn't look like the Lerp you're probably used to, but this is the correct usage of Lerp. It's basically saying every is based on time. And now if the distance here is 10, then that must have taken 10 seconds. And what I can even do is, well, I don't need to print to the screen. I'm sure it makes sense. So, oh, here, let's do this. Let's go ahead and do this. Let's do debug.log string.format. This is just for clarity's sake. We're gonna do duration distance, and we're going to say current duration total distance. So you're going to see now how this is working up here in the console. So you're going to see here, every single second this goes up, the distance is 14. So it's going to take us exactly 14 seconds to get to our destination. Now you're going to see, when we get to 14 seconds, we will have arrived at our destination. Okay, so now time is still going up, but we needed to get to only 14, so now we're there. So Lerp uses factors of time. Now if I were to multiply this by 2, then I would obviously get there in 7 seconds as opposed to 14, because it's going to double the amount of the speed that I move. Which you can see now, if you change that at runtime, you're just going to confuse it horribly, and it's going to give you extremely wonky results. Okay, I'm stuck. Please stop being stuck. What is going on with my computer? There we go. Okay, so now that you've seen Lerp, now let me show you MoveTowards. It's so much simpler, and it's going to give you the desired effect that you want. I don't even use Lerp in any of my games. I use MoveTowards. So let's take a look at MoveToward. So what do we need in MoveToward? Well, towards, that word is suddenly losing its meaning. Toward, guitar. That's another one that loses its meaning if you say it a bunch. Guitar. Okay, so again, we want our public transform start position game object public transform end position game object with a capital Go. And then in this one we do want a speed, so we're going to do, let's do public float speed, because we are going to be able to control at runtime what our speed is, which is nice. Start. Don't think we need it. We don't need to know anything. All we need to know is Well, gosh, this is just so easy. Okay, so we're going to do transform.position equals vector3 dot. See, I don't even feel like I need to explain this because it's just so self-explanatory. Move towards. We want to have, where are we now? Our transform.position. And then where are we going? Our end position dot position. And then we want to know, now the difference between move towards is that we go based off where we are as opposed to our beginning destination. And we, instead of, sorry, my brain turned off for just a second there. We don't use time anymore. Now we use distance. What move towards wants to know is what's the maximum distance it can move in a given frame. This is why you would take its speed. Let's say our object can move 5 meters per second. Then we're going to multiply that by time.delta time. And what delta time is, why does it keep adding that extra? What delta time is going to do is delta time is the amount of time between every frame, which is incredibly small. It's like 0.00 something. It's super small. Which means that we're going to multiply 5 by this really, really, really small number, by like, 0.01%. So this just means that once 1 second has passed, we will have multiplied 5 by 1, which is what gives us 5 meters per second. So it's your speed is going to be how far you travel. If you multiply it by time.delta time, it's going to be how far you travel per second. So that's how you get your meters per second. So now let's try this. Now this object, I just realized we don't use start position at all because you don't need it. It's based off of where you currently are. So our object is going to move at an angle. It's going to go from here and then move up there. So let's run this one. Let's grab our move toward and let's give it a speed of, oh, we don't actually use speed, my bad. So instead of 5 here, we're going to do speed. Okay. And we'll come over here and we'll put speed as 5. Oops. Okay. And then our end position, we're going to put here. My computer is being so slow right now. Okay. Let's try this. Let's click play. And you'll see, blink, we've moved towards at that rate. Now, that's 5 times a second, which means that we are moving 5 times faster than that, which is moving 1 meter a second. So if I change, I don't know why I brought that over, if I change this to 1 and move 1 meter per second, which is the same that Lerp currently moves, and click play, you'll see they move at the exact same speed, only because this has a little bit longer to travel because it's diagonal. It'll get there just later, but you probably won't see it. So there you have it. That's Lerp, and that's Move Towards. Move Towards is incredibly simpler. Where am I? Where am I going? And how far can I move this frame? But with Lerp, it's based on how far have I traveled and how much time has passed and all that stuff. This is good for objects that need to stay constant. They need to just move at one rate between point A and point B always, and it doesn't matter what how far away they are. It's always going to move at one constant rate. But if you have an object that needs to be constantly varying in speed, then you want to use move towards. Let's go ahead and do this real quick. Let me click on my move toward object, and if you see, if I update the speed, they move a little bit faster. And if I go negative, they move backwards. However, with Lerp, if I adjust the speed, oh, I didn't have a speed. If with Lerp, if I would have adjusted the speed, it would just jump, 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 and then continue trying to move forward from that jump position. So, okay, kind of a long video, and I apologize for how long that was. I talked as fast as I could with explaining as much as I possibly could, and I hope everything made sense. And I hope you guys go out and start using Lerp and Move Towards correctly. Let me go ahead and put this code up one last time. I'll leave it in front here, and you can copy it. You can click pause and copy it if you want to, and play with it. So yeah, so thanks for watching. Please like the video, and then again, if you have any questions, leave them in the comments below. I do my best to answer them the best of my ability. One thing I will say, if you do ask me a question based on code, it's incredibly difficult for me to help you with a problem if I can't actually see the problem. If you say, oh, I tried to attach this object, what's broken? I don't know. There's no way for me to figure that out. And I do want to help you guys, so use something like pastebin. Please don't paste code in the comment, but feel free to paste your relevant script. Don't send me your entire program, but feel free to paste your relevant script in pastebin, and if I get time, no guarantees, I'll take a look at it and see if I can't see something that's glaringly obvious. I've helped a few people already and been like, oh, you put this here, or you had this numbers there, and if you change it, you should be fine, and it's worked. And so you're welcome to do that, but again, please don't paste code in the comments, and you can use pastebin to ask me questions, and I will do my best. And again, I'm not a professional, so I will do what I can when I can. And so feel free to share this video, share it with your friends, share it with your mom. I don't care. Yeah, all right, later, guys.